Hi guys, welcome back to the daily LeetCode problem series. So let's start today's video. Okay, so today's problem is a medium level. There are n rooms labeled from 0 to n minus 1 and all the rooms are logged except for room number 0. Your goal is to visit all the rooms. However, you cannot enter a logged room without having its key. Okay. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it denoting which room it unlocks, and you can take all of them with you to unlock all the other rooms. Given an array rooms where rooms of I is the set of keys that you can obtain if you visit room I, return true if you can visit all the rooms or false otherwise. Okay, so basically, uh, the zeroth room is unlocked for us. So we will first go to zeroth room and we will collect all the keys which it contains, and then we will go to those room uh, uh, whose keys are with us. So it's like doing a DFS or BFS. So yeah. So let's say we go to room number 0. Now we have the key for the first room. Then we go to first room. Now we have the key for second room. We move on to the second room. Now we have key to the third room, and we move on to the third room. So we have visited all the rooms. Therefore, we return true. And similarly here, uh, we go to the zeroth room. We have keys to first and third room, so we can either go to first or third. It doesn't matter. So let's say we go to first room, then we have key for the third room, zeroth room and first room, but we have already got keys for these rooms, so it really doesn't matter. So we move to the third room, and we have the key for the zeroth room, but we have already visited it, so this also doesn't count. So it leaves us to the key with the second room. We have not visited the second room, so we will return false here. All right. Yeah, so it's like just a DFS. To store the rooms which we have visited, we can just create a map which will store the rooms we have visited. And let's do a BFS here. We will push the elements into the stack and then traverse it. Okay, so let's create a map which will store the rooms that we have visited. Or instead of creating a map, we can just create a vector. It will be a slightly efficient. Is visited. Let's get the size of the room. And initially, let's mark all the elements as false. And let's create a stack. Now we are at room number 0, so it is already visited. So let's push the 0th room into the stack and let's mark it visited. Okay. Now we will run our loop until stack is not empty. Right. Now we will get the top of the stack. If you guys have done the yesterday's problem, then it's almost similar to that problem. There we also did DFS, BFS, and here we are also doing BFS. You can do DFS also, it doesn't matter. So current element would be the top of the stack. and we can now traverse all the elements which are connected to the current element. So for every element I which is connected to the current element, so we can get all the elements connected to the current elements by using the rooms array, rooms of current. So now we are traversing all the elements which are connected to the current element, or all the elements uh, whose keys are present in the current room, right? So now we will just check if if it's already visited. If it is already visited, then we don't have to visit it again. So we will only check the condition when it is not visited. So if the element is not visited, then we will push it into the stack and we will mark it visited. Yeah. And we have to pop our element here also. Okay. So after this loop is completed, uh, then we will simply check if all the elements in the visited array are true. If they are not, then we will return false. So we will traverse visited array is visited, and if I is false, then we will return false. And if this whole loop runs and still we haven't got an element which is not visited, then we will return true. So let's run it. Alright, let's submit it. Yeah, so it has been accepted. It is also faster than 93%. That's good. I hope you guys like the video. I'll see you in the next one.